What's up, geometry? Thanks so much for tuning in with another episode of Math with Mullins. Today we're looking at lesson 3.2, parallel lines and transversals. And our main goal today is to use properties of parallel lines to figure out what angle measurements are equal to, prove theorems about those parallel lines, and be able to solve real life problems. So let's go ahead and jump in. First thing we're going to talk about are a few theorems. So as you need to, go ahead and pause the video and make sure you've got your notes filled in. But theorem 3.1 is our very first one. If two parallel lines are cut by a transversal, then the pairs of the corresponding angles are congruent. So for an example, angle 2 is congruent to angle 6, and 3 is congruent to angle 7. So everything that I am highlighting in green, you're going to copy in notes, okay? You should have your handout in front of you. If not, you get the amazing opportunity of copying each thing down. Theorem 3.2 is the alternate interior angles theorem, and that just says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are also congruent. So for an example, 3 and 6 are congruent, and so are 4 and 5 because they are in the alternate interior angle position. If you are not sure about what these things mean, you need to go back to lesson 3.1 right before, and that goes over each one of the areas of angles. The alternate exterior angles theorem also states that if two parallel lines cut by a transversal, then the pairs of alternate exterior angles are also congruent. So because of the diagram on the left, 1 and 8 is congruent, and so is 2 and 7. And then consecutive interior angles theorem, a little bit different. And this theorem, this is when those two pairs of consecutive interior angles, those are going to be supplementary, which means they are equivalent to 180 degrees. So if we look at this diagram up here, 3 and 5 and 4 and 6 are both going to be supplementary. So we want to make sure those are written down as well. Take a moment now to make sure if you've finished copying down 3.1, pausing here, all the way through 3.4, and when you're ready to go on, click play. All right, the measures of 3 of the numbered angles are 120 degrees. Identify the angles and explain your reasoning. So, angle 4, we will start with, it's 120 degrees because of vertical to 120 degrees, already notated. Angle 8 is alternate exterior angles with 120. And then angle 5 is another one. Angle 5 is the alternate interior or corresponding. I'm going to say corresponding though with 120, but it could also be alternate interior angle with angle 4. Okay? That's all we had to do for that one. So let's go on to the next. Finding the value of x. So we know that 115 is vertical to 4, and 4 is supplementary to x plus 5. So first, we want to make sure if this is 115, then angle 4 is equal to 115 as well. Now that we know that if we add angle 4 and x plus 5 together, they are supplementary. So that's what I'm going to show here. 115 plus x plus 5 equals supplementary angle of 180 degrees. Combining like terms means I get x plus 120 is equal to 180. And then if I subtract 120 from both sides, x should be equal to 60 degrees. Okay? You go ahead and try this one. Pause the video now if you haven't already, and then try it. Once you're done, click play to check your work. So the value of x is what we're trying to find. 136 and 7x are not alternate interior or alternate exterior, but what I do know is that I can find out what the measure of angle 1 is. Angle 1 plus 136 is 180, so all I have to do first is subtract 180 and 136. Okay, as I do that, I should get 44 degrees. So angle 1 is equal to 44 degrees, which means 44 degrees is also equal to whatever 7 times x plus 9 is, right? Because these are alternate exterior angles from here down to here. I can subtract both sides by 9. I'm going to get 37. No, 35. I was borrowing not correctly there. So 35 is equal to 7x. Then when I divide both sides by 7, 5 is equal to x. Okay. Onward. Prove that two parallel lines are cut by a transversal, then the pairs of alternate interior angles will also be congruent. So this is where we're going to write a proof. First thing we want to maybe do is just draw two parallel lines. Typically we name them like line P and line Q, but you can name them two other consecutive letters, and then we're going to label T as our transversal. And we want to make sure that if we have alternate interiors, like if this is angle 1, this is angle 2, we want to show that they are equal to one another. So I might also want to give a different angle here. So if two parallel lines are cut by transversal, then the pairs of alternate interior angles are congruent. I'm going to also add maybe, here's angle 3, just to kick and giggle it. So here we go. 1 states that P is parallel to Q, and that is the given. Okay. Then if I state that, then that means angle 1 and angle 3 are congruent. Probably should have done that. And that is the corresponding angle theorem. Because of that, and they correspond, then I can also say that angle 3 is congruent to angle 2 by definition of vertical angles, or the vertical angle congruency theorem. So that all I do now is say angle 1 is congruent to angle 2 using the transitive property of congruency. Okay, so that would be one way you could prove it. You could also prove it a different way, but this is just one of those ways I use this. You could use supplementary if you wanted to and do two consecutive angles equal 180. That could also work as well. Next, when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. For violet light, the measure of angle 2 is 40 degrees. So here's 40 degrees. What is the measurement of angle 1, and how do you know? We should know that if you continue these two lines, they're going to make parallel lines, and then this is a transversal cutting through them. Angle 1 is an alternate interior angle to angle 2. So the measurement of angle 1 is equal to 40 degrees because of the alternate interior angle theorem. Okay, that is the conclusion of our notes today. Thanks so much for tuning in.